All right, this will be part 2 of our review on polynomials. We've already talked about end behavior and direct substitution and determining algebraically if a function is even, odd, or neither. And we talked about graphically knowing if a function is even, odd, or neither symmetry. That was all in part 1. In this part, we're going to review factoring. So let's start with number 7a. When you look at a problem like number 7, you see 4 terms. You should be thinking, okay, probably grouping. That's what the first thing you should try when you see 4 terms. So let's remember grouping. You take the first 2 terms and the second 2, and you treat them like a group. Okay, looking at the first group, obviously, what's the common factor here? What's the GCF? X squared. So you take your x squared and you pull it out front. Okay? That's going to leave behind x plus 1. Now, if you look at the other set of parentheses, I already have a x plus 1 right here. Okay? So I'm just going to put x plus 1. But if I want to, I can think of it as factoring out a positive 1. Okay? Because now I can treat the x plus 1 as a common factor. And I can take that x plus 1 and pull it out front, like this. X plus 1 out front. Now that the x plus 1 is out front, what does that leave behind? X squared plus 1. Now, sometimes I'm done right now. Sometimes I have to factor further. Am I finished, or do I need to keep going? I'm done. Okay? If this had been x squared minus 1, the difference of 2 squares is factorable. I could go x plus 1, x minus 1, like that. But if it's x plus 1, that's prime. You can't factor that anymore. That's why this is the answer. Okay, the answer is x plus 1 times x squared plus 1. Okay, let's look at problem B. What is the first step of factoring, class? GCF. Is there a GCF on this problem? No, no GCF. Okay, so let's go ahead and go into our binomial times a binomial situation. Okay, first you look at that 9. Now be careful. It could be 3 times 3, or it could be 9 times 1. I would try the 3 times 3 first, just to try it out. So if I did, I would have 3x and 3x. Then I look at the 4. The 4 could either be 2 times 2, or it could be 1 times 4. I would try the 2 times 2 first. Okay, remember, inner plus outer equals middle. That's how we always did this. Inner, when I say inner and outer, I'm talking about these. This is inner, and this is outer. Inner, I have 6x. Outer, I have another 6x. I'm trying to get a middle of positive 12. All right, can I get a positive 12 out of 6x and 6x? Sure, if they're both positive. All right, that would make this positive 2 and positive 2. Will I get a positive 4 if I do positive 2 times positive 2? Yes. So that means this is definitely the right answer. So I can put a box around it. Call it a day. Any questions on part B?
Can you do the x too?
What now? Like factor more? Oh, I see what you're saying. Could I not write this as 3x plus 2 squared because it is the same thing twice? Yes, I could. Where's your phone, Joseph? Just put it on my desk. Get it at the end of class. All right. Look at, you were right. You were correct. I could certainly write it that way as well. I'll accept either. All right. Part C. Whoa, what's the first step of factoring, class? You're right. We definitely need it this time, don't we? All right. 3x squared. Thank you, thank you. So our greatest common factor is 3x squared. So we definitely want to pull that out first. once you know your GCF, you divide with it. And that's what tells you what goes on the inside. All right, 3 divided by 3, they cancel out. What about x to the 4th power divided by x squared? That's going to be x squared. All right, minus 100. Okay, because the x squareds cancel out. Sometimes I stop here because I'm done. Sometimes I keep going. Is this one where I stop or do I keep going? I keep going, don't I? How do I keep going, Mackenzie?
Is it x minus 10, x plus 10?
Isn't it x minus 10, x plus 10, Mackenzie said. And she's right. Okay? Because that is the difference of 2 squares, so you must keep going. And, of course, you bring down your 3x squared. All right, so don't forget to keep going when you can. That was a common mistake on the last test. So there's your answer to part C. Any questions right there?
I have questions for number G.
Well, you gotta wait till I get there. Okay, look at D. Are there any common factors here on D? How many times does 4 go into 125? Somebody said 4 is a common factor, so I need to know.
31.9.
Yeah, 4 doesn't go into 125. Anything else? Common factors? How many times does 5 go into 64? Yeah, it doesn't end in 5, so you know it's not going to be divisible by 5. Yeah, so there are no common factors. So, but luckily, and I hear Mackenzie saying to us, remember, this, just like we learned the difference of 2 squares, we learned a special pattern for the sum or difference of 2 cubes. And that's what's happening here. This is the sum of 2 cubes. Remember, I used to tell you guys that little list would be helpful to you. And I'm talking about this. Like, for example, 2 to the 3rd power is 8. 3 to the 3rd power, 27. 4 to the 3rd power? 64. Okay, see the 64? 5 to the 3rd power? 125. See the 125. So these are both perfect cubes, 64 and 125. And of course, a to the 3rd power and b to the 3rd power, those are cubes as well. So, get this back into your brain because all this is still on the test. Okay? Here's how we factor the sum of 2 cubes. It's always going to factor as a binomial times a trinomial. The binomial is just going to be the cube root of both terms. Okay? So what's the cube root of 64?
4.
Right, that 64 comes from 4. You see what I'm saying? It's like uncubing the 64 back to a 4 again. Okay? 4a, and then plus 5b. The cube root of 125 is 5. The cube root of b to the 3rd power is b. So there's your binomial. Okay, did I lose anybody so far? Okay, you look good. All right, no frowns. Now, this other part is a trinomial. Okay, 3 terms. I like to do the beginning and end right now. All right, can you guys remember how I used to get the beginning? Square it. Take your first term, square it, and take your last term, square it. That will give you the first and last term of your trinomial. So what will be the first term of this trinomial?
16a squared.
16a squared. And what will be the last term?
25b squared.
All right, so plus 25b squared. Don't forget the b squared. For some reason, kids leave off the b squared sometimes.
20ab.
How are you getting that?
You combine your 4a.
Right, for the middle term, you multiply the product of these two. So 4a times 5b, that's 20ab.
It's negative.
It's negative. Remember this. Remember to use SOAP. The signs, in terms of the original problem, the signs are same, opposite, always positive. So positive, negative, and the last one is always positive. So that's it. That's what we should have for D. Any questions on D? Okay. E. I feel like giving you like 1 second to do this on your own. In my last class, I think I had 2 students get this problem right. So let me see if you guys can beat their record. I'll pause the video. Hey. Yeah, so we decided this is in fact the difference of 2 squares. So if we break this down as the difference of 2 squares, tell me what it's going to start off as. 9 minus 4x squared and 9 plus 4x squared. Now, more than 3 people got this far, okay? But this is not the final answer, is the thing. Okay? Why is this not the final answer? It's kind of like a problem we did earlier. Why?
The first one isn't prime.
The first one is not prime. Okay? The first half of this problem is itself now the difference of 2 squares. So, I feel like I should have made them in different colors or something, but this one on the right is prime, so I'm just going to keep it like it is. You cannot factor the sum of 2 squares. But on the left here, which I'm going to show in red, this can factor further. And how will it factor further?
3
3 minus 2x and 3 plus 2x. So this would be the complete answer that I was looking for.
That's what I got.
This is the answer that only 3 people have. Okay. All right. Any questions about E now that you see it? So if you have a problem like this tomorrow, I don't want it to be like wrong, 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 wrong. I want at least 2/3 of you to get it right.
So this on YouTube?
Yeah.
On Mr. Beavis, what up, YouTube?
That was my boy Ashton, y'all. What's up? Number 3.
Ashton Carver, my friend.
My friend. All right. Once again, when you look at this and you see 4 terms, you should be thinking probably grouping. Probably grouping. Okay, so let's look at those 2 and those 2. The common factor here is x squared.
Can you separate them? Like put 3x3 with minus 9x and then negative 2x squared plus 6?
I will only do, if this doesn't work out in the order that's in, then I'll play with it in another order. You can. There's nothing wrong with that. But I'll always try it the way it is first and see what happens. So just taking out the x squared, barely, that's going to leave behind 3x minus 2.
Negative.
Okay, now on this one, I will pull out a negative 3. And that's going to leave behind 3x minus 2. Okay, let that sink in for a second. Notice how the parentheses are the same. So I should be able to factor out. Okay, so I take that common factor and I like to put it out front. So I put my 3x minus 2 out front. All right, that leaves the x squared minus 3 behind. Now, is this the final answer or can I factor more? That's it. We can't factor x squared minus 3 or anything like that. So that is the final answer. All right, now looking at G, and it's just me now. I don't have a class anymore. Looking at G, what's the first step of factoring? It's always to pull out the GCF if there is one. Now, clearly both of these are divisible by 2. So that should be your first step, is to pull out the common factor of 2. Okay, so that is going to leave behind x to the 3rd power minus 27. Now, I'm hoping that you recognize that this part is the difference of 2 cubes. Okay, so that 2 out there is going to stay out there. But this part, and maybe I should make it red, this part's going to factor further. Now, the pattern of the difference of two cubes is it's always going to factor as a binomial times a trinomial. The binomial is just going to be the cube root of each one of these terms. So the cube root of x to the third power is x. Now let's bring down that minus. The cube root of 27 is 3. So that's where the binomial comes from. Now the trinomial comes from squaring these two terms. Will give us the beginning and the end. Okay, so if I take this first term and square it, I've got x squared. If I take negative 3 and square it, I've got positive 9. So that gives me the beginning and the end of my trinomial. For the middle term, I multiply. Now I'm still dealing with these two terms, the x and the 3. So x times 3 is 3x. But the sign will be the opposite of what we started with. So if this is negative, then I put positive. All right, and if you need it, you can use SOAP. The acronym SOAP helps us remember the signs. Compared to the original function, when we factor, the signs are the same here, opposite here, and this last one is always positive. So SOAP, same, opposite, always positive. Okay? And that's it, except for don't forget to bring down the 2, that GCF that we pulled out. So this would be the complete answer to G. Okay? Okay, for H, what is common here? Let's see. Well, they're both divisible by 2, so let's definitely bring that out. But then there's variables, so let's see. Do both terms have x's? No, only this term has x's. Do they both have y's? Yeah, they both have y's, so that we need to bring out some y's. Specifically, this term has 3 y's, this term has 3 y's. So they both have at least 3 y's, so that's how many y's we bring out as part of the GCF. Now, on the inside, okay, remember, once I have the GCF, I'm basically going to divide by it. So I'm going to divide by 2y to the third power. Okay, 18 divided by 2 is 9, and I have my x squared there, so I have 9x squared. Y to the third power divided by y to the third power, these cancel each other out. And now I have 2y to the third power over 2y to the third power. Anything divided by itself is 1. Okay, so we need to factor this further, because now we notice that this is the difference of 2 squares. So we're going to have 2y to the third power, and then this part is the difference of 2 squares. So it's going to factor as 3x plus 1 times 3x minus 1. So that will be the answer. Okay, that was the answer to H. All right, and this is going to be the last one that we will squeeze into this video, will be I. And once again, what's the first step of factoring? That's right, look for the greatest common factor. So let's see, they're all even, they're all divisible by 4. So let's pull out a common factor of 4. Okay, so if I do that, then that's going to mean on the inside we will have 2y squared minus 7y minus 15. Okay, and if you're not sure, just do 60 divided by 4 on your calculator. All right, 60 divided by 4 That's 15. Okay, so we have this. So we're going to keep this 4, but we're going to go ahead and factor the rest of this down. So 2y squared can only factor as 2y times y. Meanwhile, 15, all right, this could either be 3 times 5 or 1 times 15. Let's try 3 times 5 first. Now remember, inner plus outer equals middle. So we're shooting for the middle. All right, now inner, all right, inner I have 3y. Outer I have 10y. Okay, is there a way that I can get a negative? I shouldn't have even highlighted the negative 28. I should have highlighted this negative 7y. All right, because this is what we're factoring. Is there a way I can get negative 7y out of 3y and 10y if I pick the signs right? Well, sure. If I go with a negative 10 and a positive 3, that's going to give us negative 7. Okay, so there's my positive 3, and this will give me the negative 10. Okay, and check one last thing. Will we get the negative 15 out of this? Well, a positive 3 times a negative 5, that is negative 15. So that is going to be the answer to part I. And I'm going to have to end this video right here because it's long enough. And we will pick up the next video, see what we're getting into. Well, we're still factoring, but we will be solving equations by factoring. I'll see you on the next video.